Hello everyone, welcome to the channel Vidyut Yog. In this video, we'll discuss rectangular to polar and polar to rectangular conversion using calculator. This video is divided into three parts. In first part, we'll discuss the necessity of rectangular to polar and polar to rectangular conversion in case of the electrical network. Then we'll discuss rectangular to polar and polar to rectangular conversion by using theoretical procedure. And in the last part of this video, we'll discuss how we can convert rectangular to polar and polar to rectangular by using calculator. So first of all, why there is a need of conversion of rectangular to polar, polar to rectangular in case of electrical engineering. Whenever we are going to solve AC circuit, at that time we show the impedance in term of the rectangular to polar, rectangular or polar form, or also we can represent the admittance in this form. Whenever we have to do the calculation, for example, suppose we have to calculate current, then current is equal to voltage upon impedance. At that time there is a need to do the division. Whenever we have to decide the power factor, we should have the idea about angle of current. At that time there is need of polar form. So we have to convert rectangular to polar or polar to rectangular for the mathematical procedures. Now mathematical procedures, that means we have to do the addition, subtraction, division or multiplication. At that time we have to use the rectangular and polar form of impedances or admittances. Now what is the rectangular form? Suppose we have to represent the impedance, then in a rectangular form it can be represented as R plus minus Jx, that is Z is equal to R plus Jx for the inductive circuit, or Z is equal to R minus Jx for the capacitive circuit. So in this case we can as an example we can see 2 plus J5 is the rectangular representation of impedance. Now polar form, so Z bar is equal to Z at an angle of theta is the polar form of this impedance. For example, Z is equal to 5.385 at an angle of 68.19 is the polar form of impedance. Now whenever we have to do the mathematical procedure, then we need to use the rectangular form and polar form. So important point, whenever we have to do the addition or subtraction, we need to use the rectangular form, and when we have to do the multiplication and division, then we have to use the polar form. So we'll discuss that part in next time or after few minutes, but right now we'll discuss how to convert rectangular form to polar form and polar to rectangular by theoretical procedure. So here Z is equal to R plus Jx is the rectangular form of impedance. Now if we have to convert this into the polar form, that means we have to obtain the same impedance in term of the Z bar is equal to Z at an angle of theta form. How will calculate this Z? So for that, Z is equal to under root of R square plus X square. This is the formula, and for calculation of theta, theta is calculated as theta is equal to tan inverse of X upon R, where value of R and X will get from this rectangular representation. Now same concept we will see with the example. Suppose you are having the rectangular form value Z is equal to 2 plus J5, then for conversion of this value into the polar form, we will calculate Z bar is equal to, Z will be calculated by using this formula under root of R square plus X square. For this example, R is equal to 2 and X is equal to 5. That's why Z is equal to under root of 2 square plus 5 square. At an angle of, how we will calculate theta? By the formula tan inverse of X upon R. So tan inverse of 5 by 2. So in this way we will get polar value Z bar is equal to 5.385 at an angle of 68.19. So I repeat, if rectangular form impedance is 2 plus j5, its polar value is 5.385 at an angle of 68.19. Now we'll see the polar to rectangular conversion by using the theoretical procedure. So z bar is equal to z at an angle of theta. This is the polar value. If we have to calculate or we have to convert this value into the rectangular form, then z is equal to a cos theta plus b sin theta is the rectangular representation, where a is equal to b is equal to z value of this polar form. That means this z we will consider for a and b value, and theta is nothing but angle theta, which is available in polar form. Now we'll see same with the help of the one example. Suppose you are having the polar value of impedance 5.385 at an angle of 68.19. Then theoretical formula is z is equal to a cos theta plus b sin theta. But we know that a is equal to b is equal to z. So for this, z is equal to 5.385. So z is equal to 5.385. Cos of angle is 68.19 plus b sin theta, that is 5.385, sin of angle 68.19, and accordingly you will get the rectangular representation z is equal to 2 plus j5. So in this way, in this slide we have discussed how to convert 2 plus j5 rectangular value into the polar and polar to rectangular value with the help of the theoretical procedure. Now this rectangular and polar value, as we have discussed, required to for mathematical procedure, and we have discussed that whenever we have to do the addition subtraction, we need to use the rectangular form, and whenever we have to do the multiplication and division, we have to use the polar form. So in this slide, now we'll go through this all the mathematical procedure with the help of the one example. So addition and subtraction is used for rectangular form, and multiplication and division we need to use the polar form. Suppose you are having the two values, z1 is equal to 2 plus j5 ohm, that is impedance 1, whose polar value is 5.385 at an angle of 68.19, and impedance z2 is equal to 6 plus j9 ohm in rectangular form, whose polar value is 10.816 at an angle of 56.31. Now suppose we have to do the addition z1 plus z2. We know that addition is done in rectangular form, so we will consider rectangular form 2 plus j5 plus 6 plus j9. So how this addition is done? So addition of real part plus addition of imaginary part. So 2 plus 6, that is 8, plus j, 5 plus 9, that is 14. So we have done the z1 plus z2. Now if we have to do the subtraction, suppose we have to obtain the value of z1 minus z2, we know that subtraction is also done in rectangular form, so we can write 2 plus j5 minus 6 plus j9. Again here for subtraction, there is subtraction of the real part and subtraction of the imaginary part. So 2 minus 6, that is minus 4, minus j in bracket 5 minus 9, that is minus j4. So minus 4 minus j4 is the subtraction or value of z1 minus z2. Now suppose we have to do the multiplication. So z1 into z2. In this case, we know that multiplication is done in polar form. That's why we will consider the polar value of z1, that is 5.385 at an angle of 68.19, into polar value of z2, that is 10.816 at an angle of 56.31. So how we will calculate this multiplication? So for that purpose, value of these magnitudes, that is 5.385 and 10.816, are multiplied in conventional way, that is 5.385 into 10.816. But in case of the multiplication, most important point, whenever we are doing the multiplication, there is addition of angle. So here at an angle of, what about these angles? It will be get added because we are going through the multiplication procedure. So 68.19 plus 56.31. So z1 into z2 is 58.244 at an angle of 124.5 degree. Now division, suppose we have to calculate the value of z1 upon z2, then it will be 2 plus j5 at an angle of, divided by 6 plus j9. But as we have discussed, for division there is a need of polar form. So polar form of z1 is 5.385 at an angle of 68.19 divided by polar form of z2, that is 10.816 at an angle of 56.31. So z1 upon z2 is equal to 5.385 divided by 10.816 division at an angle of, for division there should be the subtraction of angle, that is 68.19 minus 56.31. So z1 by z2 is equal to 0.7752 at an angle of 11.88 degree. So thus we have discussed the mathematical procedure, and when it is required, whenever you are going to find out the response of any element in AC circuit, what is the meaning of response? Either we have to calculate the current flowing through the element, or voltage drop across the element, or power dissipated by the element. At that time we need to go through this mathematical procedure, and for that purpose you should have the idea about rectangular and polar form and its conversion. Now in exam it becomes difficult to do this conversion procedure, theoretical conversion procedure, and hence you should have the idea how to convert rectangular to polar, polar to rectangular value with the help of the calculator. So now we will discuss how to convert rectangular to polar, polar to rectangular with the help of the calculator. Now we will see the rectangular to polar and polar to rectangular conversion with the help of the calculator. So suppose first of all you are having the impedance Z1 in rectangular form, that is 6 plus J9. If we have to convert this value into the polar form, first of all switch on the calculator and then press shift plus button. Then it will ask for the POL. POL means polar value. Then in polar you will get the two values from rectangular form, 6 and 9. So 6 comma 9 bracket complete is equal to, it will give us the first value of rectangular form, that is polar form, that is 10.816. Then at an angle, for angle value just press RCL tan button. Then it will give the angle 56.30 degree. Now another example, suppose you are having the another value Z2 is equal to 2 plus J5. You have to obtain this value in polar form. Same procedure, press shift plus, that is, it will ask for the polar value. Polar is 2 comma 5 bracket complete is equal to, that is 5.385 at an angle of RCL tan, that is 68.19. So you are having two values Z1 and Z2 in polar form. Now for polar to rectangular form, suppose you are having the value Z1 is equal to 10.816 at an angle of 56.3 degree, and you have to convert this value into the rectangular form. Now in this case press shift minus, it will ask for REC, that is rectangular form. So from the polar value you will get the two values, 10.816 and 56.30. So 10.816 comma 56.30 bracket complete is equal to, so it will give the first value of rectangular form 6. Then for real imaginary part of rectangular value press RCL tan, it will give the plus J 8.99. This is the rectangular value. Similarly for the polar value of Z2 is equal to 5.385 at an angle of 68.19. If we have to convert this value into the rectangular form, again press shift minus, then it will ask for the REC, that is rectangular value 5.385 comma 68.19 bracket complete is equal to, that is first value of rectangular form 2, and for imaginary part press RCL tan is equal to, that is plus J 4.99. So this is the rectangular form of this polar value. So thus we have seen how to convert rectangular to polar and polar to rectangular with the help of the calculator. Thank you.